Graham Hawkes has quite an ambition: to travel to the deepest part of the ocean. On average, the ocean floor is 3.8 kilometers below the water's surface, but its deepest point is 11 kilometers straight down. This area is known as the Challenger Deep. It lies at the bottom of the Mariana Trench, southwest of Guam in the Pacific Ocean. This ocean floor trench is at least 4.5 times as deep as the Grand Canyon. The difficult and dangerous journey to this remote place was completed once, in 1960. Ocean engineer Graham Hawkes would like to change that. He invented a new submersible, Deep Flight 1, which was able to descend 1 kilometer. Hawkes' next step was Deep Flight 2. This submersible was designed to make the journey to the 11-kilometer depth of the Challenger Deep. Unlike previous submersibles, Hawkes' creations are fast and highly maneuverable, and they use wings, but in a way you might not expect. Instead of helping to lift the craft upward as they do in an airplane, the wings on Deep Flight work in conjunction with turbine propellers to create a downward force. With this downward thrust, Hawkes hopes to descend quickly to the bottom of the ocean.
Apart from anything else, I want the fun of doing that. I don't know why I'd let a robot do it.
Hawkes believes that manned access to the ocean floor is important to understanding our planet. It's an opportunity to learn how life thrives in extreme conditions, including high pressure, low temperature, and no light. Where is the deepest part of the ocean, and how deep is it? As you watch this segment, think about the different types of plant and animal life found in each ocean zone. Even though oceans cover more than 70% of Earth's surface, until recently, very little was known about ocean life. That's because exploration of the deepest zones of the ocean is complicated by near-freezing water temperatures, extremely high water pressure, and complete darkness. Using submersibles, researchers are beginning to discover exciting information about the amazing diversity of underwater life. You might think of the ocean floor as sandy and flat, but it is actually shaped by mountains, plains, valleys, ridges, volcanoes, and just about every other geologic feature we see on land. If you started at the shoreline and moved out into the water, you would notice that the ocean floor slopes gently downward. This part of the ocean floor is called the continental shelf. The water above the continental shelf is relatively shallow, averaging about 130 meters deep. This water is called the neritic zone. It extends from the coastline to the outer edge of the continental shelf. The neritic zone is shallow enough that sunlight can reach all the way to the bottom. This sunlight enables photosynthesis to take place in this zone. With photosynthesis, there's an abundance of plant life, most of which is phytoplankton. These tiny organisms form the basis of the marine food web. Microscopic animals called zooplankton eat the phytoplankton, and in turn, they are eaten by small fish, which are then eaten by larger and larger fish. You might recognize some of the larger animals in the food web: sharks, tuna, sea turtles, dolphins, seals, and whales. But many fascinating lesser-known creatures dwell below the sunlight zone and survive in a very different environment. Beyond the continental shelf is the continental slope. It marks the end of the rocks that make up the continent and the beginning of the deep ocean basin. The uppermost part of the continental slope is an area of the ocean called the transition zone. Some sunlight penetrates to this zone, although it is generally not enough to support many photosynthetic organisms. Many animals here eat organisms that drift down from the neritic zone. Others actually swim upward at night to feed in the nutrient-rich waters. Octopuses, squids, lanternfish, rat-tail fish, viperfish, jellyfish, and hatchetfish swim in the upper transition zone. Fewer creatures live in the lower areas of the transition zone. In these darker waters, less prey is available. Like this hatchetfish, some fish have enormous eyes so that they can see in the dark. Creatures that live here have other adaptations, including sharp fangs, as seen on this fang-toothed fish, or large mouths, as seen on this gulper eel, to help them catch food. Many have slender or transparent bodies, like this squid, that help them hide from predators. Other fish are colored to help them blend in better with the dark water. Some animals that live in this zone make their own light with bioluminescence, such as this deep-sea anglerfish. Bioluminescence is light produced by a chemical reaction. Bioluminescence is a beneficial adaptation in many ways. It allows fish to identify other fish of the same species so they can find a mate, to scare away predators, and to trick or attract prey. But there is even a deeper, darker part of the ocean to explore, the deep zone. The deep zone, the largest part of the ocean floor, covers 30% of Earth's surface. Here, seamounts and deep-sea trenches are found on vast stretches of flat, sediment-covered plains. In the deep zone, temperatures are consistently near freezing and absolutely no light penetrates. The deep zone is home to the smallest variety of organisms. Only select, well-adapted animals can live here, such as six-gilled sharks and hagfish. Creatures that live at such depths often have large eyes that help them scavenge for food. Earth's deep ocean remains a mysterious place. It is estimated that scientists have explored less than 1% of the ocean floor. As technology advances, scientists will be able to more fully explore the fascinating creatures living at all depths of the ocean. Name 2 ways that bioluminescence is a beneficial adaptation for fish.